All right, guys, thank you again. Monaco, Davos Lodge, amazing panels so far. And this will be a good segue from Dustin because when Mr. Naya ended, he talked about being passionate about something. And I know, Ulf, when you and I spoke, that came through very clearly about your passion, not only with the product we're all excited about, but really about water. And so I want you to give a quick introduction and talk to us, not about the product and what you're doing, but just the impact of water and how you see water as a passion for what you're doing.
Oh, well, there's so many things about water. Obviously, we're in the drinking water space, so we're more concerned about drinking water, and obviously there's concern about water everywhere. But there are some simple facts that I think everybody's kind of aware of, and that's most of the, or let's say 1/3 of the people on the planet cannot access safe, clean, affordable drinking water. And we're starting to see impurities that we couldn't even imagine in our tap water, in our commercial water, everywhere. And not at least the problem with the plastic or the single-use plastic, where we find microplastic in Antarctica raining, and we see microplastic in a Mariana Trench. I was in Maldives like 8 months ago and had the opportunity to speak to some mosquito researchers, and they found out when you get a mosquito bite, you get microplastic in your blood. So the problem with water is obviously everywhere. 50% of the hospital beds in the world is related to waterborne diseases, which means that if we give people safe, clean drinking water, we can get rid of 50% of the hospitals. And then we have the impurities such as arsenic or fluoride. I just read that 140 million people are affected by too high content of arsenic and fluoride in their water. So, I mean, it's problematic everywhere, yeah?
And that leads us to what your company WAYOUT and the product is not. I mean, it's technology, but it's not desal, it's not reverse osmosis at a big scale. You've really taken a product down to a consumer scale that's really implementable. So tell us about WAYOUT and the product and what you guys do.
Well, it's a long story why it started, but I can run it fast because we kind of realized that we wanted to create something where packaging is not necessary. We kind of said that packaging is a design error, and we wanted to find a way to produce beverage at that time, like a watermelon and a straw. You produce where you consume. So that's the whole idea, and there's a lot of other things behind as well. So we wanted to do it in that way, but we also took basically a white paper and tried to figure out how can we build something that is future-proof with all the buzzword that we know, empowering, circular, good for nature, or whatever. And we realized that we want to create something that is a distributed technology instead of a centralized technology for resilience purpose and for utilizing the fact that water is basically everywhere and you should produce where you consume. And you should not transport, and you should avoid trying to packaging as much as possible. So it's an idea where we take basically any water source and turn it into H2O in a small micro scale, you could say, but it's 20,000 liter per microfactory. So it's still distributed technology, but it's not still in every household. So it needs to be a little bit centralized.
Yeah, but unless you see it, it's hard to understand because I'm listening to you, and the only reason I can connect the dots is I've actually seen the site and the product. So explain what the product is. Like, what does it look like and how does it work? Otherwise, we're not understanding it.
Yeah, I can understand it's challenging. So basically we have a 20-foot size container that we call a microfactory that can take any water source. And we started by doing it in a small scale because we wanted to be local. And then we wanted to create a system that is very efficient so we don't waste water. So we have a very high efficiency, what they call yield. So we have a 90% yield and we lose like 10%, while most of the municipal water system or any kind of system you have loses 50%. The water bottle is losing 66%. So in this microfactory, we treat any water to basically H2O, taking away the PFAs, microplastic, hormones, and everything, the impurities that is there. We adding then the minerals because we need with the water to be safe and nutritious. And after we added the minerals in that microfactory, we are filling vessels that is non-plastic and that is reusable. And we are also filling them fully automatic and fully sealed. It's a mechanical seal and a digital seal, which means that it's not possible to tamper with the water. In most part of the world, you don't trust the water if it's served like this. You need to have the click on the plastic bottle, or you need to make sure that it's safe. So we have that kind of safety built into the microfactory. So treatment, mineralizing, filling vessels. Then we have the vessels, which is the size of a 5-gallon approximately, that you see all over the world, where you put on dispensers. So this is then transported in a close circle because it's small scale, out to a dispenser where we have also developed a dispenser technology that kind of connect it mechanically and digitally and saying that you can open now, so it's safe. And then the vessel is returned to the microfactory, being cleaned by ozone technology. So we have no chemical usage, and as you know, ozone returns to oxygen immediately. So now we have a microfactory, the vessels, the dispensers, all connected by the cloud. So we can measure every drop, but also everything is total circular.
Yeah, and to call it a filter would be a disservice, right? So can we call it a smart filter? What
you can call it a filter because it's all about mechanical filtration mainly. So we have 8 filtration steps, but we're also using safety measures as UV lamps and even ozonated water, which is good for PFA treatment as well. So, but basically it's a mechanical filtration concept.
Yeah, and that's what we talked about. That's where I thought it was really unique, and the design itself is very beautiful and aesthetic, and Mr. McDonough is still sitting here. Thank you for staying. So a lot of your design is really not only aesthetically pleasing, but you thought through how to make it sort of recircular and repurposed and things like that. And it's a microfilter in an area that you're not transporting bottled water. You're not transporting from a facility. So there's a lot of things that in the water footprint, the virtual water footprint, you save electricity, pollution, power. There's a lot of other ancillary reductions, not just in the clean water component.
Yeah, so basically, I mean, there's a lot of, I mean, when you do things right, I think, when you have the right intention, there's so much benefit coming after you really designed it. So we realize now that we can offer our we can offer our technology to the current bottling companies that are suffering from low profit because they have to transport from A to B, which is quite far distance. We have a commercial center in Dubai. When I'm in a restaurant, I get Voss water from Norway, Fiji water from Fiji, which is insane. So here you can now be much more cost efficient as well, so saving money, but you can also saving a lot of CO2 emissions, and you're saving the plastic. So.
Yeah, and talking about emissions, I learned this a couple of years ago at GITEX Dubai, and I think it's Lufthansa, I don't remember, but one of the actual airlines has to fly water into a third foreign country. I believe it was Africa. I don't want to throw Africa under the bus, but wherever they were, the water didn't meet the standards of what was needed. So they would fly water on the plane just to have the proper certification water in that country, which to me, you talk about emissions, like that's just a fractional waste that you could really solve in a lot of things that are bigger than just a localized filter system.
Yeah, it's probably not the most modern, future-proof infrastructure to do that. So there's another example in the drought of Mayotte. If you know where Mayotte is, it's between Madagascar and the mainland of Africa. So they had a drought recently. It was on CNN, on BBC, everywhere. And the French government is obviously concerned because they are taking care of that part of the world, which is still French or EU. And they realized, or they had the idea of sending down 20 million plastic bottles per month to solve the problem. For me, that's not modern future-proof infrastructure. I just made a rough calculation that we could save them like $20 million dollars per year by putting our system there, and they could have an infrastructure for 30 years. They would have saved 200 million plastic bottles from not entering into their beaches. And they would obviously save a lot of chemicals as well.
And with the type of water input, we were talking about this. It's anything from gray water to brackish to, the filtration system you have is so dense that you can actually take any kind of water source input and make it potable.
Yeah, we kind of made a decision early and to make an industrialization version of it. All the idea for us to reach everybody, because it's a cost issue, it's a cost per liter that is by the end of the day interesting. So we said that let's industrialize it and do the same everywhere with the redundancy, so we can make basically an iPhone and make it the same everywhere, so we can bring down the cost so that we can basically reach everyone with that cost. So that's why we have a lot of redundancy inside, which means that we can basically take any kind of water source, whether it's full of arsenic, whether it's residuals from a mining company, or gray water, black water, hippo pool water, or seawater.
And so for you, as a rollout, do you see industrial or residential or hospitals? Like where are the best use cases for what you've built?
Right now, we see that the most, let's say, easy target for us, or where we like to start, is obviously where they can afford our technology at the point we are right now. And where we have an extremely good offer is for the company that is actually littering with plastic today. So it's the big corporation that is using plastic bottles today. We have an offer for them that they can use our technology and get rid of the plastic, become more profitable, and have a sustainable and higher quality of the water. So that's the first tier of our client segment. The other one is development areas, where you're not considering to build an infrastructure of pipings. It could be mega projects like in Saudi, like in Red Sea development or NEOM or any other kind of project, where they're not necessarily going to do the piping, because if you have piped water, you need to control the pipe cleanness by chemicals anyway. So by the end of the day, that's why it smells of chlorine in many places. So new development could also be an area, but we're moving very fast toward a possibility to also supply our technology to crisis area, whether it's in refugee camps, whether it's in a war zone. We are in connection with the Ukraine government to see what we can do on the front line as well. Because instead of having one centralized unit where you can bomb with one missile, we have hundreds of ours, which means that you take out one, it doesn't matter. And we have decided to never compromise with the quality of water. So we have the same microfactory, we have the same vessels, but the dispensing technology could sometimes look very nice and fancy for high-end hotels, or it could be a very easy mechanical device if you're in a crisis area. But the water quality is always the same. We never compromise with that.
And so where, in something like a war zone or a crisis zone, where does the input come from? Where's the water initially coming from?
It can come from any source. We usually say from any source to every mouth. That's our idea. So it could come from a river, it could come from rainwater harvesting, it can come from industrial waste, but we can also, through some other collaborations that we have, create water from air, to do air-to-water condensation. So basically where we have difficult to even have a water source, we can take it from the air.
And so with again, I'm always fascinated by how you roll out a product in a company and things like that. I think the hospitals also is a really interesting one, because you've got the sanity side, which impacts health and education. How would it work in a hospital setting?
No, a hospital is a good example of a venue that can be big enough to take one of our systems. Schools is another one. I just read up today that 50% of the schools in the world don't have clean drinking water. 50% of the schools. And hospitals, obviously, they need not only clean water, but safe water. So hospitals and schools are good venues that we are targeting as well.
And if you're removing fluoride and arsenic and things out of the water, you also talked about putting minerals in. How do you decide what you're going to put back into the water?
I mean, we're following the recommendations from World Health Organizations and other organizations when it comes to the recommendation of the mineralization, but you can have local preference. So, for example, in Saudi, I know that they have preference for slightly higher fluorides because probably they have some health benefits for that. We are in discussion with Rwanda that has very high fluoride in some areas, but no fluorides in other areas, and they have horrible teeth problem in Rwanda. So we're talking to them as well. They might have a higher fluoride content as well. In some areas, they don't like the fluoride. So we're trying to follow the recommendations, but also open to listen to local requirements and ideas.
And we'll finish up with this one because we've done a lot of work with disaster management. You know, we get called in after hurricanes on stuff, and one of the first things they do, and Hurricane Katrina was horrible. Haiti was a great example. The disaster people will fly water in on pallets of water. And Haiti, we talked about this. They fly it in with no place to store it. The bottles are sitting out on the tarmac. They get heated up. The bottles are exploding. You know, so water also has a weight. You're talking about 8 pounds per gallon. So when you're flying all of this water into disasters, it's so counterintuitive to what needs to be done. You know, so for disaster deployment, have you guys looked at that as well in terms of earthquakes and hurricanes? There's always that need of water right into the center of the disaster.
No, absolutely. And I mean, some of the disasters is even flooding, and some of the areas which is flooded have problems of getting clean drinking water. So it's almost like a joke. So our system is deployable, plug and play. It's ready to go, it's built in. You just put the power, it could be solar, it could be anything, and you put the hose in with water, and that's it. So we take another 2-3 days to install, and obviously there is a time for shipment or sending it. But basically any kind of disaster, we could come in a week, and we can be there, and we can give clean, safe drinking water.
Yeah, and so that's where I got so fascinated with the technology. Is it's industrial, it's commercial, it's hospital, it's education, it's disaster management. Just such a great wide application for what you've built, and again, it's a smart filter. So we won't pejoratively just call it a filter. A lot of technology built in. Let's wrap up here, Ulf, and talk about where you see the future of the impact of your product in terms of health and some of the disaster. I'm fascinated by the disaster area, but really the transference of health to clean water. Talk about your vision of what your product could do and help along those lines.
Well, I mean, all of these numbers I was mentioned in the beginning, we like to participate to help to eradicate those problems, of course. And we see ourselves as a potential new paradigm in making drinking water and distributing and dispensing drinking water. But I more than that see our technology as an example of for other technologies to move from centralized to decentralized, and also local empowered technologies that can be used using the resources locally for the people locally that should own that, and not like it is today that we make water in one place, deplete the aquifer, sending it to some other place, taking their money and dropping the bottles there, and then go home and use the profit somewhere else. So I think it's just a way of doing it right.
And for everybody who doesn't know, just what's the name of the company? Because I mentioned it briefly, and it doesn't seem like something that instantly screams water.
The name of the company is WAYOUT, and we have a couple of explanation and reason for that. One is obviously we wanted to create a way out of the current matrix. Another thing is that we wanted to enable our technology to be placed anywhere, far out, way out. One of the first installation we have is out in Serengeti, as far out as you can come, way out, where they actually produce the water from borehole filled up with fluoride. Usually you cannot use it. Filtration company usually doesn't want to deal with that. And from solar panels. So it's completely circular and sustainable in that. And earlier there were transporting through a diesel truck 8 hours through Serengeti back and forth, in with and out with plastic. So that's gone. So way out also for some people means being a little bit crazy. So maybe that's a part of this story too.
All right, well, thank you so much. Thank you, everybody here. Thank you to
you.
Monaco and the Davos Lounge.